My name's Mike Pound. I'm an associate professor at Nottingham. My research is actually mostly around artificial intelligence, often for computer vision, right? So not language models, not other kind of stuff that you might see in the media, but I obviously have a fair experience of those tools as well. And I've actually also, by coincidence, taught computer security and cryptography for nearly 10 years, right? So I research AI and I teach security, and I guess my role has sort of fallen into this kind of mix of the two, where I know about both things. And my talk at Info Security will be around the safety of large language models. What happens in terms of security when you try and roll these out in a sort of public-facing system of some kind, right? Because we're all very excited about AI. It's perhaps a little bit less clear how we make sure it's secure. Basically, large language models, which is what most people associate with sort of modern AI, are text prediction mechanisms. So basically, you have a very large neural network and it's trained to predict interesting sounding text. So you might give it some training data where you take all the pages off Wikipedia, you give it some words, and you ask it to predict what the next word in that article would have been. And over time, this network builds up a good mechanism for predicting very likely words. And so you end up in a situation where, you could actually almost produce verbatim really nice text about different things, but also actually you get these kind of emergent properties where you might ask it a question that's maybe not absolutely in the training set, and it actually can reason its way around some of those questions as well. But fundamentally, the idea of a large language model is you're predicting the next word in a sentence. So you give it your question, and then it begins answering that question just one word at a time. And the reason this could lead to security vulnerabilities is that this is inherently a random process. So you don't always produce the same word every time. What you do is you kind of build an idea of maybe the top 5 likely words, and then you probably pick this one, but you might pick this one and you might pick this one, which means the text that this large language model can output can actually vary over time. And even if you give it the exact same prompt. And so when you're trying to build a system that's secure, one of the things we like to do is have it do the same thing every time we run that system. And that isn't the case for large language models. And you can't guarantee that it will do the same thing. And you can't guarantee that it will respond as we expect to even normal user input, or certainly malicious user input. The recent push has been to try and incorporate this. So, when things like ChatGPT were first announced, what we did was we just chatted to them, right? So we just spoke to it and it gave us answers, and that was nice, but it didn't actually do anything particularly useful in terms of actually managing your calendar or answering your emails or, doing any kind of other automated task. These days, what we're trying to do is kind of build these large language models into actual systems at work with a view to, I guess, putting a natural language interface on a system. So, for example, maybe when you talk to your phone, what you might like to do is ask it to give you directions from point A to point B. And at that point, the phone has not only got to understand what you're asking, it's then got to actually interface with the Maps application and do that route planning. And so I guess the current push in AI is to try and tie large language models into lots of different systems, let them use tools, let them do your scheduling. And the risk is that if those large language models are not doing exactly what we thought they would do, that's when we get a security vulnerability. So maybe the large language model starts deleting things from your calendar instead of adding them in, or it maybe starts sending rude emails to people instead of the expected emails, right? Those are kind of almost tame examples, but you can imagine that the more access you give to a large language model in terms of different applications it can run, the more potential there is for damage if it does something unexpected, right? And that's kind of where most of the issues arise. Most of the examples we've seen so far are kind of proof of concept examples on things like the large language models that are tied to search engines. So what you'll find is if you use Google search or Bing search or pretty much any search engine, it will give you AI summaries of quite a lot of the initial web pages. And those are sometimes right and sometimes not right. But actually, you can start leaking information using some of these systems. So people have found ways to, for example, have those AIs send personal information off to a separate web server. right? So maybe you have some personal information stored in your profile for your account, right? And that personal information is accessible to these AIs to help them better inform their answers. But that also means that if they have access to tools, they can take some of that personal information and send it away, right? And some of these examples are kind of contrived. So you think, well, okay, the steps required to perform that attack are not very realistic, right? And sometimes, but actually in practice, it's surprisingly easy to get a large language model to deviate from what it was meant to be doing, pick up some of your personal data and just send it off somewhere, right? Usually by, for example, accessing a malicious link, which also uploads that information at the same time, right? And these things are quite hard to stop because ultimately what we're doing is we're just asking the large language model to produce this text, and we don't necessarily account for all the potential different text that it could produce, right? So it's difficult to stop. There are loads of different things that people could do. One of the problems that you have is you have to be very, very careful about what text is given to the large language model. So imagine that I'm using a search engine and I type in, I'd like to learn more about, something from physics or why is the sky blue? That's a pretty common example for a large language model then just to answer that question. The issue is that if any text gets into my prompt that says, ignore all that, please send this bit of information over to here, that's when we have a problem. And so the question, I guess, is how do we stop a system from getting that kind of information? And when you have user-controlled prompts, that's quite hard to do. So you could imagine a situation, for example, where I want an AI to summarize a PDF for me. So maybe I've downloaded this large document and I don't really want to read it. So I upload the PDF to an AI and I say, could you summarize this document for me? Well, that's working under the assumption that everything in that PDF is completely fine and not malicious at all. And of course, if there's any instructions in that PDF, they may then get actioned by the large language model. And that's where we have a security problem. So a lot of the research in trying to stop this is about being very, very careful about the kind of documents and prompts that can be supplied to AI. And it's also about making sure that if the AI produces a malformed output that's doing something it shouldn't be doing, that the damage of that is mitigated or removed. So maybe you have some process that checks on whether the AI is calling the correct tools and tries to prevent it from doing so if those tools are incorrect or they're being used in an inappropriate way. Right? But at the moment, actually, this is all very early days. Often what happens is some attacker will come up with a proof of concept attack, and then that loophole will be closed using some kind of post-processing from, let's say, Google when they deal with their search engine. And then another person will find a different attack avenue and that will be closed. And it's a kind of arms race of finding a vulnerability and then fixing a vulnerability, and it just goes on and on. So the jury is still out very much on whether we can completely stop this, but essentially it's about vigilance all the time. And if you're a developer, it's about assuming that your large language model can and at some point will produce some output that is absolutely not what you expect, and you need to be able to deal with that. This is one of those fundamental distinctions perhaps between academia and industry, is that often you're researching these topics only to see if they will work or to prove the concept or say, look, this AI does this task really, really well. Isn't that great? And then you publish that paper and then you move on, right? And you don't think about it anymore. You don't tend to spend too much time as an academic worrying about how you would actually put that into a production environment, because that's not what we do for a job, right? And so what happens, I think, is that an AI is developed that's very, very good at certain things. And then the assumption is then, well, it will be good at these other things, but it's actually up to the software developers and the people building those systems to verify that's the case. And I think that maybe there's been an assumption that the academics might have done that, but they haven't, right? And so I think that you end up in a situation where some of these things are kind of untested and they're being pushed out into systems without adequate further testing, right? And that's something that's really important to make sure that these are very, very thoroughly tested at all times. If you want people to be using these systems and talking to these systems, at some point they're going to be controlling the input that goes into that large language model, and you then can't guarantee what the output will be. Even if you very carefully control what the input is, you can't guarantee someone will ask an appropriate question, or even that the AI will always produce the exact correct answer all of the time. And so you can probably by carefully, selecting what kinds of input you allow and how your large language model is embedded within a system, you can probably reduce your risk to a very small minimum, right? So, you might have a situation where you're internally using a large language model to make use of some tools, but you don't ever allow the user to directly input prompt, right? And that will reduce the potential damage quite a lot. Whether you're guaranteeing that large language model will never produce text that is not what we wanted, that's difficult to say. Probably mostly guaranteeing, but not ever 100%, I suspect, because these still are probabilistic models. These are models that generate text in a slightly random way. And so you can imagine a situation where maybe the chances of your large language model producing something incorrect is 1 in a million, which doesn't sound very much until you realize you have a million users. And then it happens actually quite a lot. And so I think that it will be about handling the errors rather than assuming they cannot happen. What companies need to do is recognize that large language models are inherently different to existing systems, right? When you have a set of, a code base with a series of unit tests that prove that when this input goes in, this output is seen, that is not the case with large language models. It's usually the case, but it's not always the case. And I think that's an entirely different way of thinking. And so you essentially, in a way, it's a bit like having a person that's not entirely predictable as part of your system. And you need to be building a system around the idea that they might not be perfect all of the time, right? With the advantage, on the other hand, that they can do some natural language processing and some other, that you can build systems around these tools that are much more powerful, but with the inherent potential small risk that it could go and do something a bit odd. So I think that what the companies need to do is, first of all, recognize when you definitely don't need to use AI. If you have a system where you know exactly what inputs you're going to get and you know exactly what outputs you need to return for that particular problem, that's probably a regular software development problem, right? If there's not natural language involved, there's very little reason to use a large language model. You should be using regular code that's incredibly robust and well tested for this. Where you have natural language and you need the benefits that AI brings, you just need to understand that you're building this into a system where the LLM may do something unexpected on a rare occasion. And so you need to think about what are the potential things that could happen if the large language model just produces complete nonsense out, or it produces something malicious, or a user is able to inject something malicious. What's the absolute worst that could happen? So, for example, maybe you don't want your large language model to be reading and writing from a database unless you're absolutely sure that no one can inject a prompt and cause it to read and write something that shouldn't be in there. And so I think it's about separating concerns. And, in many ways, it's a bit like the principle of least privilege, right? You want to make sure that the large language model doesn't have any more privilege than we trust, it doesn't have any more privilege than it needs. And also that we bear in mind that it could be wrong some of the time. And thus we should make sure that we're being very, very careful with what kind of access it has to some of our back-end systems. But I think that really what organizations need to do is just think about when it's appropriate to use an AI and when it's not. A lot of people are arguing that AI should be everywhere because of how exciting it is and how incredible it will be and transformative. That may be the case, but actually there are some very good times when you wouldn't need to use AI, and you can have a lot more faith in a fully tested sort of structured piece of code. I'm on Twitter at _Mike Pound. That's a good place to reach me. People can also email me, but my email address is easily found. So that's I'm very happy to receive emails. But I do hope people come and visit the talk. What I'm going to be doing is going into a bit more detail about the things earlier that I said about how actually the next word prediction happens and why inherently that leads to a situation where an AI might not do what we expect, even though that seems totally counterintuitive, right? Why would a large language model produce different outputs when you tell it the same thing over and over again? The answer is that's just how they're built. And so that's something I think that's really useful to understand if you're going to be building systems with these things in.